Hello guys, let's look at problem 6. It's a question about geometry. It asks you to find the area for this shape. We can say that this shape is very central symmetric, so we can absolutely find a circumcircle for this. We find the center of this shape, and we also have OA equal OB equal OC equal OD equal OE equal OF equal OG. And obviously we have 7 identical parts as shaded in green color on the screen. So we have 7 identical green parts. If we want the area of the whole thing, we only have to solve the area of the green sector. Not exactly a sector, the green part. How are we going to solve that? I divided into 2 parts. The first part is this, second part is this. So S1, the first part, it actually equals the area of the sector AEB. So I write it like this. So the sector of the AEB minus the area of the triangle ABE. Here we go. And for part 2, the second part, it is just a triangle. This area of a triangle called AOB. So one thing we cannot skip is we have to know the nonce of the radius of the circumcircle. Let's say it is R, and since R is a circumcircle of ABE, the triangle ABE, we can use something from the sine rule. Let's recall what sine rule is. So sine rule is something A equals sine A equal B over sine B equal C over sine C, and the most importantly in this question, equal 2 times radius. So if we can know, so let's look at what we already know. So we know the angle of this angle called angle AOB. We know it has to be 2 pi over 7 because these 7 degrees, they are totally the same by symmetry. They're totally the same. So what we know is, to start with, angle AOB equal 2 pi over 7. And then we can get angle AEB equal half of the angle AOB. It is going to be, we see, pi over 7. And we have A equal B, so this is also something. So in the question, we basically said diametrically opposite the midpoint of the arc. So we know that EO must bisect the angle AEB. And if we expand EO, it should lie exactly on the midpoint of AB. We have AB actually equal. So we find if we say the midpoint of AB is M, so AB equal twice of the nonce of BM, which is 2 times B times sine half of the angle AEB. That would be 2A times sine pi over 14. Basic trigonometry. And yeah, so then we get the nonce of AB, but that's not the end. We have AB so that we can try to apply sine rule to get the radius R we want. So the radius R equal R, use another color. So R equal 2 sine A divide A. So it's A over 2 sine A. we know that A, what we get is AB, which is 2A sine pi over 14, and 2 sine A is 2 times sine pi over 7. Pi over 7, right? Yes, so that will be times sine pi over 14 over sine pi over 7. Since another thing we should notice is pi over 14 2 times pi over 14 equals pi over 7. So actually we can apply double angle formula here for, I think, for the denominator. So it will be actually 2 times sine pi over 14 times cosine pi over 14. So then we can get rid of sine. The answer is A over 2 cosine pi over 14. Yes, so we get it. In fact, maybe we don't need sine rule to get it, but this is quite straightforward and don't really require any deep thinking. We can do something, maybe just play some tricks in the triangle, but that's just not that easy. That's a little bit that require more thinking. So now we get the radius, the length of the radius R, and let's keep executing our plan. So let's go for S1 first. Let's go for S1 first. So S1 equal the we have used a larger sector subtracts the triangle. The larger sector, we have the formula half times A squared times the angle, which is pi over 7, and we use it to minus the triangle. We use a sine rule also. We use a sine rule for area too. It will be 1 over 2 times A squared times sine pi over 7. So for this part, it's square root minus sine pi over 7. This is for S1. Now we are looking at S2. Yeah, so S2, it is actually S2 equal 1 over 2. Yes, it's half times R squared. Half time R squared times sine. What's the angle for AOB? The angle for AOB is 2 pi over 7. 2 pi over 7, right? Did I make a mistake? No, I didn't. And we substitute the result we get above for R times A squared 4 cosine squared pi over 14 times 7 to pi over 7. Yes, I think so. Now we only have to add S1 and S2 together. Looking at the result we want, we see tangent, so we will think about how we transform sine and cosine into tangent maybe. And yeah, only A and some trigonometry. That's the form we want, at least. So now we add them up. Final result, hence S1 plus S2, which is the S we want, equal 1 over 2 R squared 7 pi sine 7 pi over 7 plus 8 times sine pi over 14 sine pi over 7. Yeah, we were thinking. So for this part, it will be, maybe you should get an out square. So that's what we want. I think we're lacking something, but let's go. Let's keep going and see what we get. Sine will equal 2 sine pi over 7 sine pi over 7. And we can actually keep it going. So for sine pi over 7, we still apply the double angle theory. Let's get 2 times cosine pi over 14 times sine pi over 14. Yeah. Is that correct? 8 over cosine squared pi over 14. So we use the double angle theory multiple times. I hope it works. So for here, we get cosine out. Yeah. Yes. Maybe it helped. Let's see what's going on. So square with cosine pi over 7 is tangent pi over 14. But that's still a little bit far from what we actually want here. We can already substitute, can already factorize, get a squared over 2 out of what we get. So maybe that's good. But there are also some distance, though. So let's continue our solution to this problem. We have already found S1 plus S2, which is the surface of the red part. But what we want is actually the whole area of the coin. So that means we have to multiply the thing we get here by 7. So that would be the final answer we want. Yeah, here we go. And that is a little bit different from the one given in the question. We should compare their difference. Actually, we should have confidence in our approach that it is not wrong. The next step should be to prove that they are actually equivalent. So yeah, what we are going to prove is actually minus 7 sine pi over 7 plus 7 times cosine pi over 7 times tangent pi over 14 equal minus 7 times tangent pi over 14. That is what we are going to prove. Yep. And we should get rid of the 7 thing because we can cancel 7, of course. it will become just simpler. I would say we just move everything to the left hand side, and now that we are going from what we want to something that clearly makes sense. For now, we set pi over 14 equal alpha and pi over 7 equal 2 alpha, which just simplify our proof, and we can get a very general conclusion here. So cosine 2 alpha times, so we don't want tangent here, we want only sine and cosine. Only sine and cosine. So that we can maybe execute some trigonometry transformation easier. Yes. For now we multiple cosine alpha, so we get rid of fractions. So here, I would say this question, so my solution just involves basically double formula for sine and cosine. We expand sine 2 alpha here. Not cosine 2 alpha, not that hurry. In case you don't know, cosine 2 alpha has two ways to expand. One way involves only cosine alpha, one way involves only sine alpha. We don't know it's necessary that we use it. And which one to use, we don't know. So let's go. Let's just expand sine 2 alpha first, which has only one way to expand, in fact. And for now, actually, we can factor out sine alpha for this equation. And let's see what happens. Okay, so sine alpha times cosine 2 alpha plus 1 minus 2 times cosine alpha equals 0. So what in the bracket is actually the formula for double angle of a cosine 2 alpha, which only involves cosine alpha, as I read on the right hand. So yeah, we have really reached somewhere that clearly makes sense, that clearly stand. And as we can going up and up, get what we want actually. But here we have to write the double direction arrow, which means if and only if. In this way, we can really get it, really succeed in proving this. Yeah, it's valid, and finally we get it. We prove the yellow part so that we can prove that our answer equals a squared over 2 times pi minus 7 tangent pi over 14. So this is the end of my solution to problem 6. I will say my solution is quite done and maybe requires some skills for calculations, but I still show it to you. But before talking about why I make this video, I want to introduce another method provided by the book by the author, which is way easier. So that's a difference I called addition or subtraction. What I do is actually addition, but the best approach should be subtraction. So we both want the area for the purple part, which is ABO. That is not a regular shape. That's not a sector. That's not anything. What I do is just divide them into two parts, S1 and S2. And I do some calculation to find their value. So I use addition, so the part ABO equal S1 plus S2. But the answer provided by the book is subtraction. So it subtract double the surface of AOE from the triangle or the sector. So he subtract double the area of triangle AOE from the sector ABE. And actually the area of triangle AOE is quite easy to find out because the AE or AB is known as A, and the height, which is a perpendicular distance from O to B, can be found out by just tangent. Like the height is just literally something half A times sort of tangent or something like that. And this will be very close to the final answer. The reason why I provide my answer is it shows that you can do the proof if you have the proper skills, you have the basic skills. You can do it anyway.